Good morning. In this lecture, I'm discussing the task 4. In task 4, the first question, A question. Write a C program to check whether the given number is perfect number or not. Given number is a perfect number or not. What is exactly perfect number? Suppose, for example, if I gave the number is the 6, what are the divisors of the 6? That is the 1, 2 and 3. If I sum that one particular numbers, that means sum of its proper divisors, that is the 1 plus 2 plus 3, that means it will contain the 6. If the result of this one is equals to that particular number, at that time that particular number is the perfect number. Once again I am repeating. If the number is a perfect number, the sum of the divisors is equals to that particular number, at that time only that particular number is a perfect number. Here I'm checking the 6. What are the divisors of the 6? That is the 1, 2 and 3. The sum of these divisors, 1 plus 2 plus 3. The sum means that is the 6. The 6 is equals to that particular number, previous number. That means if it is equals, that particular number is the perfect number. Understood? Now, for this one, how to write the program? Now here, int I num sum equals to 0, printf enter any number to check perfect number, scanner percentage d ampersand num. I think up to here we can easily understand. Calculate sum of all proper divisors. For I equals to 1, I less than num by 2, I plus plus. I equals to 1, I less than num by 2. That means we have to check the divisors. If num modulus of I equals to 0, at that time sum equals to sum plus I. For that one, sum plus equals to I. Understood? If it is equal, if sum equals to num, printf, that is the perfect number. Otherwise, not a perfect number. Once again, I am repeating. Here, this is the logic. For I equals to 1, I less than num by 2, I plus plus. If num modulus of I equals to 0, if num modulus of I equals to 0, at the time sum equals to sum plus I. If sum equals to num, perfect number. Otherwise, not a perfect number. Understood? Next one, B question. Write a C program, check whether the given number is palindrome or not. Here, we have to check that the number is a palindrome or not. I think we know that in palindrome. Suppose, for example, if the string is made up, MADA, if it is reverse, that means reverse of that particular string is also made up. Both are equals means that is the medium is the palindrome. But exactly in the case of the number, if I put the reverse of that particular number is equals to original number, it will give you the original number means that is the palindrome. Suppose for example input number that is 121. If the reverse of this particular number is the 121, so that 121 is the palindrome. Understood? Now for this one program, intent num or ev, enter any number to check palindrome, scanner %d ampersand m, that means taking the data from the user. Num equals to n, that means copy the original value to num to n. Now find the reverse of the n and store in REV. While n, that means we have to calculate the, that means we have to take, how to do the reverse of that particular number. While n not equals to 0, reverse equals to reverse into 10 plus n modulus of 10. See here, reverse equals to reverse into 10 plus n modulus of 10. Next one, n equals to n modulus of 10. This is the logic. Reverse into 10 equals to, suppose for example, reverse equals to reverse into 10, reverse equals to 0 initially, 0 into 10, that is the 0 plus n modulus of 10. N modulus of 10, suppose for example, if the user gave the n equals to 121, 121 modulus of 10, that means it will give the remainder 1 only. That means REV contains the 1 only. N equals to n modulus, n division of 10. It is given the 12, n contains the 12. While n not equals to 0, 12 not equals to 0, REV equals to REV. REV means that is the 1. 1 into 10, that is the 10, plus n modulus of 10, that is the 12 modulus of 10. It is given the 2. That means 10 plus 2, 12. N division of 10. Like this one we have to calculate. Understood? Now, next one. Check if the reverse number is equals to number or not. That means REV. REV contains the reverse number. Num contains the original number. If the reverse equals to num, that is the palindrome, or otherwise else not a palindrome. Understood? This is the logic. Reverse of that particular number. If the reverse of a number equals to original number, that is that particular number is the palindrome, otherwise not a palindrome. Next question. Write a C program, check whether a given number is the Armstrong number or not. Write a C program, check whether a given number is the Armstrong number or not. What is exactly Armstrong number? So I will give the example. Suppose for example 371. We have to do the that means individual. What is the individual digit? That is the 371. 3 to the power of 3 plus 7 to the power of 3 plus 1 to the power of 3. 3 to the power of 3 plus 7 to the power of 3 plus 1 to the power of 3. This is the 3 only. It is not visible. 3 to the power of 3, 7 to the power of 3, 1 to the power of 3. It is given as 371. That means individual digits of the power, that is the power of the, that means 3 power of 3 is given that particular original number. That number is the Armstrong number. Here how many digits are there? That is the 3. So that one 3 to the power of 3, 7 to the power of 3, 1 to the power of 3. Understood? So here what is that Armstrong number? The Armstrong number is a n digit number that is equals to sum of the n to the power of a particular power of its digits. For example, here sixth, that is the only one digit is there. 6 to the power of 1, that is the 6. 371, how many digits are there? 3. 3 to the power of 3 plus 7 to the power of 3, 1 to the power of 3, 371. The 371 is the Armstrong number. Power means we have to take that on how many digits in particular. Okay, understood? Now, the program. Simple program here. Here I am using the math.h also. Why I am using the math.h means here I am using the mathematical functions. That is log 10 and also round function and also power function. Round function and also power function. So that one I am using the math.h. Okay. Now the original number, num last digit sum equals to 0. Original number equals to num. Digits equals to int log 10 of num plus 1. Now calculate the sum of power of digits while num greater than equals to 0. Extract the last digit, that is the last digit equals to num modulus of 10. Okay. Sum equals to sum plus round of power last digit comma digits. Next one, remove the last digit, that is the num equals to num by 10. See here once again I am repeating. Last digit equals to num modulus of 10. Next one, compute the sum of power of last digit. Sum equals to sum plus round power last digit comma digit. Num equals to num equals to num by 10. Num equals to num by 10. Now, after that one, how to check that the particular number is the Armstrong number or not. If original number equals to sum, printf, that is the Armstrong number. Otherwise, that is not a Armstrong number. Once again, I am repeating the logic. Here, sum equals to 0, original number equals to num, digits equals to int log 10 num plus 1. That means digit takes the number of digits in the particular number, while num greater than 0, extract the last digit equals to num percentage 10. Sum equals to sum plus round of power of last digit comma digits. Remove the last digit, num equals to num by 10. Next one. Check for the Armstrong number. That means if original number equals to number, that is the Armstrong number, else not a Armstrong number. Thank you.